At peak production, a completed B-24 Liberator rolled out of Ford's Willow Run plant about every 63 minutes. Not a Jeep, not a truck, a 4-engine heavy bomber built to cross oceans, carried tons of bombs and survive enemy fire. Just listen to the scale of what was leaving that factory floor. Each B-24 contained hundreds of thousands of parts. It had 4 Pratt & Whitney engines, fuel tanks spread through long wings, miles of wiring, hydraulic systems, gun turrets, armour, radios, instruments, and a fuselage large enough to swallow a small house. And because the war kept changing, the aeroplane kept changing too. So how did Ford take one of the most complicated machines of World War II and force it through something like an automotive assembly line? That 63-minute number sounds impossible until we stop looking at the finished bomber and start following it through Willow Run. Before Willow Run, airplanes were not built the way cars were built. A pre-war aircraft factory looked less like a moving assembly line and more like a giant workshop. Skilled mechanics, machinists, sheet metal workers, electricians and inspectors moved around partially finished airframes, solving problems as they appeared. Parts were drilled, trimmed, bent, checked, and often adjusted by hand until they fit the airplane in front of them. That was normal. Aircraft production depended on small batches and constant judgment because the machines were changing while they were being built. A new radio installation, a different gun position, stronger armour, revised fuel plumbing, or a fix from combat reports could change the work on the factory floor. Drawings arrived, were revised, and then revised again. The consolidated B-24 Liberator came out of this world. It was already in production before Ford entered the story, and it was an important long-range heavy bomber. But in a traditional aviation plant, building one was slow, specialised work. The B-24 was not just assembled, it was fitted together by people who understood metal, tolerances, wiring, hydraulics, and all the little compromises that made a huge aircraft fly. Ford came from a very different universe. In automobile production, the goal was repeatability. The same part had to fit the same way every time on the next chassis coming down the line. Workers did not stop to custom fit a fender for each car. Machines, gauges, jigs, and standardized steps made the process predictable. Aircraft fought that kind of control. They demanded precision like automobiles, but they also carried constant engineering changes, tight safety requirements, and systems packed into thin aluminium structures. A car could tolerate a slightly awkward assembly method, a bomber could not tolerate a fuel leak, a misrouted cable, or a wing section out of alignment. So when Ford looked at the B-24 and imagined building it like a Model T descendant, the idea was not simply ambitious. It was a collision between two manufacturing cultures, aviation's custom craft tradition and Detroit's obsession with flow. By late 1940, Washington could see the shape of the war coming, even if the United States was not yet in it. Britain needed bombers. American planners expected production targets far beyond anything the aircraft industry had ever handled. So the federal government turned to the one company that seemed to understand mass production at an almost impossible scale, Ford. The request was not for Ford to design a new airplane. It was to help build the consolidated B-24 Liberator, a heavy bomber already needed in huge numbers. Ford's first serious look came through Charles Sorensen, the company's hard-driving production chief. Sorensen was one of the men who had helped turn Ford's factories into machines for making machines. Sorensen travelled to Consolidated's plant in San Diego and watched the B-24 being built the aviation way. What he saw alarmed him. Aircraft moved slowly through the plant while crews worked around them. Assemblies waited on parts. Skilled workers solved fit problems in place. The process could produce bombers, but not at the pace wartime planning demanded. Sorensen later described the visit like a manufacturing emergency. He studied the airframe, the work sequence, the parts flow, and the bottlenecks. Then came the story that became part of Willow Run legend. Overnight, in a hotel room, he sketched out an assembly line system for building the Liberator in major sections, with parts feeding the line in a controlled rhythm. Whether every detail of that story happened exactly as remembered matters less than what it reveals. Ford believed the bomber could be broken down into repeatable operations: wings, fuselage sections, wiring, sub-assemblies, tools and gauges could be organised so the aeroplane advanced through production instead of sitting still while workers came to it. That belief was bold enough to sound reckless. Ford had made cars cheap, fast and consistent by forcing complexity into a system. Now it wanted to do the same with a long-range bomber containing hundreds of thousands of parts. Detroit looked at the B-24 and saw flow. The B-24 would answer with resistance. The site Ford chose was not in Detroit, but open farmland between Ypsilanti and Belleville, Michigan. It sat far enough from the city to offer space, yet close enough to draw on the region's roads, rail lines, industrial suppliers and workers. In April 1941, construction began on what was meant to become one of the largest factories on Earth. The architect was Albert Kahn, already famous for designing industrial buildings that could move material with minimum wasted motion. At Willow Run, his job was not to create a beautiful landmark. His job was to wrap a building around a production system big enough for a 4-engine bomber. The result was a factory of roughly 3.5 million square feet. From the air, it looked less like a building than a district. Inside, the B-24 was supposed to move through stages of production the way a car moved down a Ford line, with each section, tool and crew positioned for the next operation. The main assembly line ran nearly a mile. Parts and sub-assemblies fed into it as the bomber took shape, from major fuselage sections to wings, landing gear, wiring, engines and final equipment. The famous feature was the 90-degree turn in the line, a sharp bend built into the layout so the plant could fit within county boundaries and tax rules. A heavy bomber in the middle of production had to flow around a corner. Willow Run also needed a city's worth of support. New roads carried workers and materials to the site. Housing projects and trailer camps grew around the plant because thousands of employees could not simply appear in rural Michigan without places to sleep. Nearby, an airfield allowed completed Liberators to leave the factory by flying away from it. That detail mattered. Willow Run was not just a room where airplanes were assembled, it was a controlled pipeline starting with raw material and parts arriving from across the country and ending with a finished bomber on a runway. The building was the first machine Ford had to build. The harder machine came next, a schedule that made every part from a rivet to a wing panel arrive at the exact place where the line needed it. A Ford the Fifth 8 automobile was complicated, but it was still a product Ford understood. It had roughly 15,000 parts, and the company had spent decades learning how to make those parts repeat, fit, and move down a line. The consolidated B-24 Liberator was a different kind of machine. A single bomber contained approximately 450,000 parts. It used about 360,000 rivets in hundreds of sizes driven through aluminium skin, frames, spars, ribs and brackets. Even before engines, guns and radios were installed, the airplane was a giant metal puzzle that had to remain light enough to fly and strong enough to survive combat. Its wings carried fuel tanks, control cables, hydraulic lines and structural members that had to hold under enormous stress. The fuselage was divided into sections for the nose, cockpit, bomb bay, waist and tail. 4 engines had to be mounted with oil systems, exhaust systems, fuel feeds, cowlings and fire protection. Landing gear had to retract, lock and absorb the shock of a heavy aircraft returning to Earth. Then came the combat equipment. The Liberator needed powered turrets, machine guns, ammunition feeds, bombs, bomb racks, oxygen systems, radios, navigation instruments, flight controls, electrical wiring, heating, de-icing equipment and emergency gear. A mistake in a family car could mean a recall. A mistake in a bomber could mean 10 men trapped over enemy territory. Ford's instinct was to freeze the design, build permanent tooling and make every station repeat the same operation all day. That was how a moving assembly line became fast. The problem was that the B-24 would not stay frozen. Crews came back from combat with reports. Guns needed better fields of fire. Armour had to be added. Fuel systems needed changes. Turrets were revised. Radio equipment changed. Military specifications shifted as the war moved from planning rooms to actual air battles over Europe, the Atlantic and the Pacific. Each change travelled backward into the factory A new bracket could alter a panel, a new turret could change wiring, weight, balance, and the work sequence. A part already ordered from a supplier might no longer match the aeroplane being built when it arrived. That was the central B-24 problem at Willow Run. Ford wanted an aeroplane that behaved like a car, standardized, repeatable, and locked into permanent tooling. The war demanded an airplane that kept changing while thousands of workers were already trying to build it at speed. Ford's answer was not to make aircraft workers faster, it was to change the work itself until it looked more like automobile production. In the traditional aircraft industry, much of the tooling was soft. That did not mean careless, it meant flexible. Skilled mechanics used templates, temporary forms, hand tools, and judgment. If a panel came in slightly off, they could trim it. If holes did not line up perfectly, they could fit the part, adjust the edge, and make the assembly work. The airplane was built by people who knew how to compensate. Ford wanted compensation removed from the system. Hard tooling meant permanent dies, fixtures, gauges, and jigs that forced a part into the same shape every time. Instead of asking a craftsman to interpret a drawing, Ford wanted a machine, a die, or a fixture to define the answer before the worker touched it. A stamped rib should match the next stamped rib. A drilled bracket should land in the same place on the next airplane. A gauge should tell a worker immediately whether a part passed or failed. At Willow Run, aluminium parts were die stamped into shape. Long sections were roll formed through machines that bent metal to a repeated curve. Massive jigs held fuselage sections and wing assemblies in position while workers added frames, skins, stringers, and rivets. Fixtures located holes, angles, and edges so that one shift could produce the same subassembly as the shift before it. This was the heart of Ford's gamble. If every part could be made interchangeable, then the factory did not need thousands of master aircraft craftsmen at every station. It needed workers trained to perform specific operations quickly, in the same order, with the same tools. That idea solved one problem and created another. It made training possible at enormous scale. A new employee did not need years of aircraft experience to learn one drilling operation, one riveting pattern, or one inspection step. But the system depended on the tooling being right, the drawings being current, and the incoming parts matching the fixtures. When those conditions held, Willow Run could move with astonishing speed. When they failed, the line exposed every mismatch at once. So the question became unavoidable. Could Ford replace the old master craftsman model with specialized labor and hard tooling without turning speed into a new source of defects? Inside Willow Run, a B-24 did not begin as a bomber. It began as hundreds of separate jobs moving through different parts of the plant. In one area, workers built wing sections in large fixtures, adding ribs, spars, skins, and long rows of rivets. In another, fuselage sections took shape around frames and stringers. Tail assemblies were built apart from the main body. Engine mounts, control surfaces, bulkheads, bomb bay structures, and internal supports all moved through their own stations before they ever met the rest of the airplane. The factory was laid out so these pieces could converge. A worker on the line might drill the same holes all day, another might buck rivets on the same panel joint, another might install a bracket, check a gauge, or route a short section of tubing. Most were not building an aircraft from beginning to end. They were completing narrow operations, timed and repeated, so the next crew could take over without stopping. As the sub-assemblies came together, the airplane slowly became recognizable. Fuselage sections were joined, wings were attached, the tail went on, landing gear was fitted into place. Engines were mounted forward of the wing, turning the structure from an aluminium shell into something that looked capable of flight. Then came the systems that made the bomber more than a shape. Workers installed wiring harnesses, control cables, hydraulic lines, fuel tanks, pumps, instruments, oxygen equipment, radios, gun mounts, bomb racks, and interior fittings. Every one of those systems had to pass through crowded spaces already filling with other parts. A mistake made early could block a crew several stations later. The line demanded motion, but the airplane demanded accuracy. Cables had to move freely, fuel lines had to seal, electrical connections had to be correct, controls had to respond in the proper direction, landing gear had to lock. Engines had to connect to fuel, oil, ignition and control systems before they could ever be run. So the B-24 rolling through Willow Run was never simply complete or incomplete. It was a moving stack of finished work, unfinished work, checks, fixes and discoveries. Each station pushed it closer to the flight line, but each station could also uncover something that had to be corrected. By the time the bomber neared the end of assembly, it had the outline of a combat aircraft. Wings spread, engines installed, tail standing high, landing gear beneath it. But it was not ready for war yet. It still had to survive inspection, testing, engine runs, and the constant rework that followed when mass production met the reality of a complex aircraft. The machines at Willow Run were enormous, but the plant ran on people. Over its wartime operation, roughly 42,000 workers passed through the system, filling jobs on the line, in inspection areas, in tool rooms, offices, maintenance crews, transport teams, and training programs. Many of them had never built an airplane before. Some came from farms, stores, schools, and small workshops. Others had experience in automobile work, but aircraft production demanded different habits. A car could tolerate certain variations. A bomber carrying fuel, oxygen, bombs, electrical systems, and 10 men could not. Training turned new hires into specialists. Workers learned how to read simple drawings, use jigs and gauges, drill clean holes, drive and buck rivets, identify parts, and follow written procedures. They were not expected to understand the entire Liberator. They were expected to do one assigned operation correctly, again and again, at the pace of the line. That pace shaped life inside the factory. Willow Run worked around the clock, with shifts changing as the plant kept moving. Crews had to arrive on time, find their station, collect tools, handle parts already in motion, and leave the job ready for the next group. A late part, a wrong measurement, or a missing tool could ripple far beyond one worker. Quality control added another layer of pressure. Inspectors checked dimensions, fasteners, wiring, seals, and assemblies before work disappeared behind panels or moved beyond easy reach. Rework was part of the process, but too much rework threatened the schedule Ford had promised. The human assembly line depended on discipline as much as speed. Thousands of individual actions had to connect without confusion. Training records, parts deliveries, tool setups, inspection stamps, shift handoffs, and supervisors tracking problems in real time. Willow Run could produce bombers at astonishing speed only when all of that lined up. The line moved fast because human work, machines and parts synchronized into one enormous system. Ford had proven that cars could be broken into repeatable steps. Willow Run tested whether that same logic could survive contact with an airplane that refused to behave like a car. The B-24 Liberator was not a stamped steel body rolling toward an engine in stall. It was a stressed aluminium structure full of curves, ribs, spars, wiring runs, fuel lines, turrets, control cables, and surfaces that had to meet aircraft tolerances. A small error in a hole pattern could throw off an entire assembly. A warped panel could become a rework problem that followed the bomber down the line. Aluminium created its own lessons. Ford's teams knew presses, dies and fixtures, but aircraft aluminium demanded careful handling. It could wrinkle, stretch, crack, or lose accuracy if a forming operation was wrong. Parts that looked simple on paper could become bottlenecks when the metal did not behave the way automobile steel behaved. Outside the plant, skeptics watched closely. Experienced aircraft builders doubted that automakers could walk into aviation and simply apply Detroit methods. Their argument was not that Ford lacked machines or ambition. It was that airplanes changed too often, required too much inspection, and punished overconfidence. Then the war itself kept changing the product. The Liberator was not frozen in one perfect design while Willow Run tooled up around it. Combat reports, military requests, and engineering revisions kept arriving. A change to armour, wiring, guns, radio equipment, or structural details could force new drawings, new fixtures, new parts, and new instructions. That exposed a weakness in rigid standardization. Ford wanted a stable sequence, one part, one operation, one timing pattern, repeated endlessly. Aircraft production demanded flexibility inside that sequence. When a revised part did not match an old jig, the line could not simply wish the problem away. Work paused, inspectors flagged defects, tool rooms modified equipment, and unfinished bombers waited. The early results were frustrating. Output lagged behind the promises attached to the plant. Some assemblies required too much hand fitting. Some stations were still learning how to build at aircraft quality while maintaining automobile speed. Every delay became evidence for critics who believed Willow Run was an expensive experiment built on a false assumption. But the failure was not permanent. Ford's engineers, supervisors, inspectors and workers slowly absorbed the rules of airplane production. Tooling improved. Training became sharper. Change control became more disciplined. Parts began arriving with fewer surprises. The system did not become effortless, it became workable. After months of painful adjustment, Willow Run's rhythm steadied, and the number of finished Liberators finally began to climb. By 1944, Willow Run had reached the statistic that turned the factory into a legend. At its peak, the plant is commonly cited as completing one B-24 Liberator about every 63 minutes. Some accounts give slightly different figures depending on the date range and what they count, but the meaning is the same. Ford had pushed heavy bomber production into a rhythm no one had expected from a converted automobile empire. That number needs careful handling. It did not mean workers started with raw aluminium and built a complete bomber in 63 minutes. A Liberator still took enormous labour, thousands of parts, layers of inspection, and many stages of assembly. The 63-minute figure meant that completed aircraft were emerging from the end of a long, continuous production pipeline at roughly that interval. Think of the plant as a moving river of partially finished bombers. One section worked on sub-assemblies, another joined fuselage sections. Others installed wings, engines, wiring, controls, turrets, and equipment. Inspection teams checked the work as the aircraft advanced. By the time a finished B-24 rolled out, many more were already behind it, each at a different stage, each moving toward completion. And when that pipeline worked, the payoff was visible outside the factory doors. Finished Liberators left Willow Run for flight testing, delivery, and war service. For a moment, let the machines speak for themselves. The sound matched the scale. Willow Run was not producing a symbol for a poster. It was feeding a global air war with long-range bombers built to cross oceans, strike targets, and return with crews aboard. Each finished aircraft represented sheet metal, engines, instruments, armament, paperwork, training, inspection, and the coordination of thousands of people. In the end, Willow Run produced 8,685 Liberators, including knockdown kits shipped for assembly elsewhere. That total made Ford the largest producer of the B-24. The factory had not made aircraft simple, it had made their complexity repeatable. What Willow Run proved was powerful, but narrower than the legend suggests. It proved that automotive standardization could be adapted to aircraft production when a company was willing to redesign parts, redesign workflow, build new tools, retrain workers, and accept compromises that aircraft engineers had not originally planned for. The key word is adapted. Ford could not simply copy a car assembly line and run bombers down it. The B-24 was larger, more delicate, and far less tolerant of small errors than an automobile. Its design kept changing as combat experience produced new equipment, new armament requirements, and new fixes. Every change could ripple through jigs, parts bins, drawings, worker instructions, and inspection routines. That is why Willow Run belongs in history as an industrial breakthrough, not a magic trick. The factory turned variation into routine. It made thousands of workers productive on unfamiliar tasks. It forced military aviation and mass production to meet in the middle, where perfect custom craftsmanship was too slow and pure automobile logic was too rigid. It also did not win the production war alone. The Liberator came from a network of manufacturers, including Consolidated, Douglas, North American, and Ford, with suppliers spread across the country feeding engines, instruments, guns, radios, tyres, aluminium, and countless smaller components into the system. Across all makers, roughly 18,500 B-24s were built, making it the most produced American aircraft of the Second World War. So the famous 63-minute figure should not be treated as proof that bombers became easy. It is evidence that a vast production ecosystem had learned how to deliver complexity at speed. Willow Run did not make the B-24 simple. It showed how an industrial nation could organize enough people, machines, materials, and discipline to keep sending complicated aircraft out the door. Willow Run answered the question at the heart of this story. Ford did not make the B-24 simple. It broke a difficult aircraft into repeatable work, then built a factory disciplined enough to keep that work moving. The 63-minute bomber was not just a measure of speed. It was proof that an industrial system could make complexity move. If you want more stories about how industry reshaped war, subscribe to the channel. Thanks for watching, and comment with the wartime production story you want explored next.